So, we've looked at how doping silicon with other elements can provide us with an extra free electron, or a valence shell with 7 electrons that really would like another electron to be happy. This is what we call a hole. It just means that there's a spot for an electron to settle down into if it comes by too close. We talked about how electrons ping around easier when there are only a few in the valence shell, and how more electrons in a valence shell will absorb that energy and hurt the transfer. Simply, a substrate with an extra electron is a great conductor and it lets currents flow super easily. A substrate with a lot of holes makes a great insulator and makes it very difficult for current to flow. It's far easier just to use an element with the required electrons in its outer shell if you're looking for either a conductor or an insulator by itself. The magic happens when we put those two elements on the same substrate. If we dope one part of the silicon wafer with boron and the other part with phosphorus, we get some really useful properties. So, if we have half of our device with free electrons and half of our device with holes, something interesting happens in the middle. Since they're on the same substrate, there's some area between those regions that free electrons are super close to an area with free holes. If you've ever let a balloon go before you tied it, you can instinctively recognize that things in the area of high density want to disperse into an area of lower density. Well, the electrons along this region are going to settle down into those holes, and everything there is going to be happy. There's a line where there's no free electrons and no holes. Everything has 8 electrons in the valence shell, and the region makes a very good conductor, insulator. The region is called the depletion region. What's neat about the depletion region is that we can make it more narrow or wide depending on external factors. If it's super wide, it's going to be too big of a gap for many electrons to get through, and current through the whole device will be minimal. If we get that gap super narrow, current will not have a problem getting through. How do we do this? Let's go back to 3rd grade. Remember how like charges repel each other and opposites attract? Electrons have a negative charge, so the side with all the free electrons will be considered more negative in relation to the side with all the holes. From now on, we'll call the region with all the free electrons the N region, and the side with all the holes the P region. If you put the negative side of a battery on the N region and the positive side of the battery on the P region, the like charges are going to repel each other so that the electrons on the N region and the holes in the P region kind of start squeezing toward the middle. This makes for a smaller depletion region, and current will be able to flow. This is called forward biasing. If we do the opposite and take the negative side of the battery and attach it to the P region and the positive side to the N region, the electrons in the N region will be attracted toward the positive terminal and the holes will be attracted to the negative terminal. This will pull everything away from the middle and increase the depletion region. When you have the depletion region gap so big, current will not flow. This is called reverse biasing. Now, this is a pretty simplistic way of looking at things, but everything holds up fairly well for our needs. By having a device with just these two regions, we now have what's called a diode. You can think of a diode as a one-way valve for electricity. It allows current to flow in one direction and not the other. Think of a check valve. You have a ball, a spring, and a hole that the ball is not big enough to go through. The spring pushes the ball against the hole, and one direction the fluid will be pushing against the ball in the same direction, forcing it to cover that hole forcefully. No flow. Cover that hole forcefully. No flow. Now, if we try to send a fluid in the opposite direction, the fluid will actually be pushing the ball out of the way of the hole, and as long as the flow is strong enough to overpower that spring that's holding the ball against the hole, it'll move out of the way and fluid can flow. A diode is a very important device in the world of electricity, and understanding how it works underneath is going to be key to understanding everything else we'll talk about when dealing with solid state devices.